For the second part of our video, we do need to do steps 3 and 4, but so far we have applied the leading term test and determined that the left and the right sides both go up. That was the first part here. And then the second part of our directions, we have determined the zeros and stated their multiplicity by substituting in 0 for y and then finding those x-intercepts. Now we're ready to find a few additional points and come up with the graph. When you do steps 3 and 4, I would go through and do those at the same time, really. I'm going to start with a little bit of number 4, doing some graphing, and then I will find a few additional points, whatever a few means. So let's take what we just talked about here and put those on a graph. So there is an XY coordinate system. And what we're going to do with that is we are going to put in the things that we do know. Let me start with what we did in number 2. We found zeros or x-intercepts at 0, -1/3, and 2. So as I go through and graph that, I can come up with those values. So at 0, let me use red maybe. That might show up a little better. We'll see. Yeah, that's not too bad. We have at 0 an x-intercept. At -1/3, we have an x-intercept. Those are right next to each other. And then we also have one at 2. So those are our x-intercepts based on the work that we did in part number 2 of this problem. The other thing that we do know also is that the left side and the right sides go up. So in the middle part of the graph is going to be bouncing up and down somehow. We're going to hit the x-axis 3 times, but eventually, if you go over to the right far enough, the graph is going to go upward. So it's going to look something maybe like that. And the same thing over on the other side. The left side also goes upward. So we bounce around here in the middle, but if we go far enough to the left side is going to go up also. So let me just put what we know on the graph. That's what we know so far from parts 1 and 2. The directions did tell us for step number 3 to find a few additional points. Well, what points do we need to find? Well, it kind of depends on the problem. Here is what we know. The 0 that's furthest over to the right is here at 2, and I know what happens after that point. It goes up. And the 0 that's over furthest to the left here is at -1/3, and I know what happens over to the left of that. It goes up. What I need to do is I need to know what's happening in between those two x-intercepts. And there's only one nice integer value here in between, and that's at 1. So I would make an XY table, and I would plug in a couple of x's and figure out a couple of y's. But this one only has really one decent point to plug in, and that's when x is 1. So I'm going to take, and I'm going to substitute 1 into our original equation and calculate a y value, and that will give me another point. If there were other numbers between these x-intercepts that were nice integer values, I'd plug in a few more in my xy table. Plug in 2, 3 of those, and then you're good. If you plug in 1, you do get 4 for the y value in that original equation, so just plug that back into the original equation. So that means the point 1, 4 is another point that's on the graph. So 1, 4, that's here. And now I have enough information where I can come up with a reasonable sketch. These points that I have graphed, those are going to be exactly in the correct spot. And then everything else after that is going to be a rough sketch. We're just going to get the shape right. So how do we figure out that if it starts over here at the top on the left side, how do we figure out how it's going to go through all of these points and then finally go up on the right side? Well, that comes back to the multiplicity. So let me talk to you about that. So here's what we had for step number 2. We said that 0, -1/3, and 2 were x-intercepts. So I put those on the graph. And this is how the multiplicity plays into this. When you have an x-intercept, one of two things happens. Let's say on your x and your y axis, you're looking at a graph and you know that there's an x-intercept somewhere. Sometimes your x-intercepts are caused by graphs that go through the graph. Maybe it starts below, and as you go up above, there's an x-intercept there. Or maybe when you are doing your graph, it comes down and goes through again. So this is an example of a couple of x-intercepts that actually go through the x-axis. They start below and shoot straight through and then go up above, or they start up above and shoot through and then go down below. But there is another way that you could get an x-intercept. And that is if you have a graph where you are starting maybe up above, for instance, and as the graph comes down and it hits the x-axis, instead of going down and through and below, it bounces back up where it came from, and you end up with an x-intercept there. That's a possibility. It could also do the same thing but from the bottom. So you might have a graph that comes up from the bottom, hits the x-axis, and then goes back down, causing an x-intercept. So those are the two different things that could happen. Those are the two ways we can get an x-intercept. And the multiplicity tells us which one of those things happen. If you have something that is multiplicity 2 or 4 or 6 or 10 or 22, something that is multiplicity and it's even, then that is kind of like a parabola. And what's going to happen is the graph is going to come down from the top and hit the x-axis and then bounce back the same direction it came from, or the other way around. It'll start from the bottom, it'll go up and hit the x-axis and then go the same direction. So at 2, at this point right here, we have multiplicity 2, which is even. That means that at this point, the graph is either going to come up from the bottom and hit it and go back the same direction, or come at it from the top and go back the same direction. The other two zeros are multiplicity 1, which are odd numbers. So at 0 and at -1/3, our graph is going to go through those points. It'll go from the top and straight through down to the bottom, or it'll come up from the bottom and go straight through up to the top. So with that in mind, we can come up with our graph. So over on the left side, I know the graph is going up. And as it comes down, it's eventually going to have to go through -1/3. I look and I see that -1/3 is multiplicity 1. That's an odd number. That means it's going to have to go through -1/3 and go down below our line. So this is going to come down something like this, and it'll go through. Once it goes through, it has to turn around and then come back and go through the next x-intercept. And the next x-intercept is at 0, and when I look at that, it is also multiplicity 1, which is an odd number. So it goes through our graph at -1/3, then it turns and goes back up, and it goes through the graph at 0. So there are two x-intercepts there, and it goes through both of those. Goes from the top through down below, and then back up through and goes up above again. It does have to go through this point 1, 4, so let me go up there. And then it's going to have to come down and either go through or hit the x-axis again here at 2. But I see that it is multiplicity 2. That's an even number, so this is going to come down and hit the x-axis, but then it has to go back up the direction it came, which makes sense because it needs to go back up on the other side. That is a reasonable sketch for our graph. We had two more things we needed to finish up on this problem. We had a few more points we had to find. We only found one, and that's fine. And then we also had to come up with a sketch of the graph. So there are parts 3 and 4. When you are doing part number 4, coming up with the graph, go ahead and get your x-intercepts on your graph and put in what the left and the right sides are doing, either going up or going down. And then the rest of it you should be able to figure out using multiplicity. How does that graph go through our values? You may need to include another point or 2 or 3. I wouldn't do more than 3, just to give yourself a little bit more structure with that graph. If you want to check your work, go back to your graphing calculator, type in the original, and then you should see something that looks like this. But remember, only our x-intercepts and the point that we found, those are the only things that are 100% accurate. Everything else in this problem is going to just look the same in terms of its shape. So you should see a graph that starts up here at the top, comes down and goes through -1/3, turns around and then comes back up through 0, 0 again, hits the point 1, 4, eventually comes down and hits 2 on our x-axis, then bounces. It doesn't go through, it bounces and then goes back up to finish the graph.